This is part 2 of the video introduction to activity 3.3, where we'll focus on non-rectangular X figures. How do we work with non-rectangular X figures? For many of our algebra piece model computations, we will need to create a rectangular array of algebra pieces, find the edge sets of the array, and then use the edge sets to solve the question at hand by setting each edge set equal to 0. For example, consider the function y equals x squared minus 4. Based on our previous work, you might notice this is the graph of the parabola y equals x squared shifted down 4. And when graphing this function, you can see that the x-intercepts are located at x equals plus or minus 2. Furthermore, this helps us see that the factored form of y equals x squared minus 4 equals y equals quantity x minus 2 times quantity x plus 2. Looking at this x figure for y equals x squared minus 4, we see that it's 1 black x square and 4 red tiles. It is not yet a rectangular array. Before we add 0 pairs to create a rectangular array, still with net value y equals x squared minus 4, let's explore the regions in a factored quadratic expression rectangle. Here are the factored regions. There are 4 of them. We'll just call this whole thing a factor rectangle. Region 1 is a rectangle of black or red x squares. You can have any number of either black or red x squares arranged in this area. Region 2 is a vertical arrangement of either white or opposite white x strips. You can have any number of either white or opposite white x strips arranged vertically. Region 3 is similar to Region 2, but the white or opposite white x strips are arranged horizontally. Region 4 can have any number of either black or red tiles arranged in a rectangle. Notice that the edge set at the top of our factor rectangle consists of plus or minus x strip edge pieces followed by black or red edge pieces, and the edge set down the left is similar. Thus, regions 1, 2, 3, and 4 marked on the diagram match the dimensions of the edge pieces. For example, a white edge x strip edge piece times a white x strip edge piece is x times x squared. That would be 1 black x square in region 1. Similarly, if the top edge starts with 3 white x strip edge pieces and the left edge set starts with 2 opposite white x strip edge pieces, then region 1 would be negative 2x times 3x, negative 6x squared, and would be a 2 by 3 array of red x squares. For region 2 in this diagram, the edge pieces will be a white or opposite white x strip edge piece at the left, possibly more than one, and black or red edge pieces at the top, resulting in vertically arranged white or opposite white x strips. Similarly, region 3 at the bottom left has black and red edge pieces at the left and plus or minus x strip edge pieces at the top. And then finally, region 4 corresponds to black or red edge pieces at the left and black or red edge pieces at the top. How do we add 0 pairs to make a rectangular array for y equals x squared minus 4? Continuing with these ideas, we can now add 0 pairs of white and opposite white x strips to our model to create a rectangular array. Let's start by adding one zero pair of one white and one opposite white X strip to our X figure. We already have one black X square and 4 red tiles. Can we make a rectangle? You can see that we have the red tiles arranged in 2 ways, a 2 by 2 array of red tiles or a 1 by 4 array of red tiles. You can see that neither one of those, the edge pieces, will match. You can see that adding one zero pair does not make a rectangular array. There are not black or red edge lengths to match the needed array of 4 red tiles, which can only be 2 by 2, 1 by 4, or 4 by 1. Let's add a second zero pair for a total of 2 white and 2 opposite white X strips to our X figure. This does allow us to make a rectangle and add edge pieces with dimensions that make sense. So here you can see we've had 2 X strips and 2 opposite X strips. These locations could be reversed. Notice here we have x minus 2, and here we have x plus 1. And here the plus 2 times the minus 2 gives us our minus 4. So this does work. Region 1 is x times x, x squared. Region 2 is x times 2, 2x. Region 3 is negative 2 times x, negative 2x. And region 4 is negative 2 times 2, negative 4. Our diagram works, and furthermore, we can see our factored form, y equals quantity x minus 2 times quantity x plus 2. We see this in the edge set dimensions. Notice this diagram can also be formed with the left edge as x plus 2 and the top as x minus 2.